In simple linear regression, we have discussed modeling the linear relationship of one independent variable, y, and one dependent variable, x. In this video, we will discuss modeling the linear relationship of one independent variable, y, and multiple or more than one independent variables, x1, x2, up to xn. So the simple linear regression model is written as y hat equals to a plus bx. The estimated multiple linear regression model is written as y hat equals to a plus b1 x1 plus b2 x2 up to the number of your independent variables. A simple linear regression model with one independent variable fits a regression line such as this one over here in a two-dimensional space. Meanwhile, a multiple regression model with two independent variables fits a regression plane such as the one over here in a three-dimensional space. So if you have three independent variables, you would have four-dimensional space. Imagine an example where the dependent variable is the reaction time. So reaction time of students in a cognitive experiment or task. So reaction time measures how quickly an organism, for example humans, respond to a stimulus. In this example, the reaction time is dependent on three other variables, including the number of hours slept the previous night, the IQ scores of the student, and the caffeine intake before the experiment. So we have one dependent variable, which is the reaction time, and three independent variables. So if there is only one independent variable over here, the IQ level, you know about, for example, 25% of what you need to know to make an accurate prediction of their reaction time in the cognitive task. However, if another independent variable is added over here, the number of hours slept the night before, then by using two independent variables rather than one independent variable, we have improved our ability to make accurate predictions about a student's reaction time in a cognitive task to about 59%. However, notice that the reaction time is dependent on the IQ level or IQ score, and the reaction time over here is dependent on the number of hours slept the night before. But the IQ level and the number of hours slept the night before are not related to each other. So as long as there doesn't exist any relationship, any linear relationship between IQ level and the number of hours slept the night before, the linear relationship between the independent variables are called multicollinearity. So as long as there doesn't exist multicollinearity or overfitting of the data, multiple linear regression would help improve our ability to make accurate predictions about the dependent variable. So again, the estimated multiple linear regression model for two independent variables is written in this way. Y hat equals to a plus b1 x1 plus b2 x2, where y is the dependent variable, x1 and x2 represent the independent variables, a over here is the intercept, and B1 and B2 represent the two regression coefficients. So what if you have three independent variables in your multiple linear regression model? Your model will be written as y hat equals to a plus b1 x1 plus b2 x2 plus b3 x3. Let's look at this example. We wish to predict the reaction time of students in a cognitive task. It is known that the reaction time is affected by caffeine intake and by IQ level. So reaction time will be our y variable or our dependent variable. Caffeine intake will be our first independent variable or x1. And IQ level or IQ score will be our second independent variable or x2. The table below presents reaction time, caffeine intake, and IQ scores of 15 students who participated in a cognitive experiment. Use the multiple linear regression model to predict the reaction time for a student with caffeine intake of 12 milliliters and IQ score of 97. Let's have a look at the data. Okay, our reaction time or the y variable and our first independent variable, caffeine intake or x1 and IQ score x2. Okay, so this is the data. The reaction time is in milliseconds. The caffeine intake is in milliliter and the IQ score doesn't have any unit. So in order to calculate the multiple linear regression model, before we predict the reaction time, we would need a few values. If you still remember, we have two independent variables and one dependent variable. Our model will look like this. Y hat equals to a plus b1 x1 plus b2 x2. In order to get the values of a, b1 and b2, we need to first calculate the values of the sum of squares of y, sum of squares of x1, x1, sum of squares of x2, x2, sum of squares of x1, y, sum of squares of x2, y, and sum of squares of x1, x2. Okay, so the formula to calculate b1, b2, and a is given over here. Now, calculating the values would be very easy using Microsoft Excel. The sum of y squared, the sum of y, the sum of x1, the sum of x1 squared, the sum of x2, the sum of x2 squared, the sum of x1 multiplied by y, the sum of x2 multiplied by y, and the sum of x1 multiplied by x2. So these values are easily calculated using Microsoft Excel. Okay, so we copy and paste the data in Microsoft Excel, and then we could calculate the values of y square, x1 square, x2 square quite easily. Okay, so we will use Excel to perform the multiple linear regression analysis and to obtain the values of the intercept and the regression coefficients. So I would first go to data and then data analysis over here. Okay. And then I would continue to choose regression and click OK. Alright. So you will be prompted to input the Y range. Okay. I would choose all of my Y variable or the dependent variable, including the label. Okay. And next, input the X range. So our independent variables are the caffeine intake and the IQ score, okay, X1 and X2. I would select both, including the label. You do not have to do so. Okay, you could select only the data. Okay, and I'm selecting the range of all of the values of X1 and X2, including the label over here. So I would tick the labels over here to indicate that I have selected the labels as well. All right. And then at the confidence level, if you're prompted to calculate the confidence interval, then you may enter your confidence level over here. Otherwise, you would just ignore the confidence level. Because I have prepared a question on the 98% confidence interval, I would change the confidence level to 98%. Okay. And then the output range would be starting from over here. And that is all. I would click OK. Okay, so this is our summary output based on our multiple linear regression data analysis with Microsoft Excel. Okay, so once you finish the multiple linear regression analysis, this will be your summary output. You would first have your regression statistics over here, and then the ANOVA table for the hypothesis test, which we would conduct in a short while, and the final table with the values of the coefficients, the confidence intervals, and many other important statistics results. Let's look at the value of the intercept and the two regression coefficients. Okay, so the value of A is 91.5627 and the value of B1 is 0.2316. The value of B2 is negative 0.9598. Okay, to answer this question, use the multiple linear regression model to predict the reaction time for a student with caffeine intake of 12 milliliters and IQ score of 97. Okay, that's quite easy. It would be equals to A plus 12 multiplied by the value of B1 plus 97 multiplied with the value of B2. Okay, so the predicted reaction time for a student with caffeine intake of 12 milliliters and IQ score of 97 is 1.2383 milliseconds. So the predicted multiple linear regression model is y hat equals to 91.5627 plus 0.2316 x1 minus 0.9598 x2. And to predict the reaction time, we simply substitute the values of 12 and 97 into the multiple linear regression model. Substitute 12 over here, substitute 97 over here, and you would get your answer, 1.2383. Okay, so you may be even asked to interpret the values of the coefficients of the multiple linear regression that you have calculated. And I have an easy way out for you to interpret your coefficients. So we start with the value of B1. Okay, I would start with this section, the average, because the value of B1 is positive, so I would write it as the average increase in Y. So Y was our reaction time, okay? The average increase in reaction time corresponding to a 1 unit change in X1. So X1 was the caffeine intake in milliliter, and X2 is the IQ score. Okay, so the average increase in reaction time corresponding to a 1 unit change in X1. That would be 1 milliliter change in X1 would be caffeine intake, while X2 would be the IQ score, remains constant, is 0.2316 milliseconds, because the reaction time, the unit is in milliseconds. Okay, let's interpret P2. Okay, and the value of P2 is negative 0.9598. So the average, this would be decrease because our B2 is negative. In Y is our reaction time corresponding to, so 1 unit change in X2. X2 is our IQ score. Without a unit, I would simply write 1 unit change in IQ score, while X1 is the caffeine intake, remains constant, is 0.9598. This would be in milliseconds, because we have already written that there would be a decrease in reaction time. We do not need to write out the negative sign over there. Okay, so it is noted that the reaction time will decrease as the IQ score changes. The most important hypothesis test for the multiple linear regression analysis is the model utility test. So in this model utility test, we would conduct an F-test or an ANOVA to test the hypothesis or to compare a model with no independent variables. So if the B1, B2, if all of the coefficients is equals to 0, there would be no independent variables. So we would compare this model with no variables with the model we have already specified just now. Okay, the model with 2 independent variables that we already specified. So a regression model with no independent variables is known as an intercept-only model, because it only has the intercept without any independent variables. This also means that there is no linear relationship between all of the independent variables with our dependent variable. So the first step is to write out the hypothesis. In this case, we only have two independent variables. We will stop over here. Okay, and the alternative remains a constant. Okay, at least one of the independent variables is not equals to 0. So once we have written our hypothesis, the next step is to calculate the test statistic. And to calculate the test statistic, we would need an ANOVA table. Okay, the test statistic would be the F value over here, or the F star. And before we calculate the F star, we need the sum of squares of the regression, sum of squares of the error, sum of squares of the total. These values are easily calculated using the formula over here. Okay, so we already have the value of B1, B2, sum of squares of x1y, sum of squares of x2y. Okay, so the sum of squares of regression measures the amount of variability in the dependent variable that is explained by the independent variables. So the amount of variability in y that is explained by x1 and x2 in our model. Okay, and then we have the total sum of squares, which tells us how much variation there is in the dependent variable. So this is equivalent to the sum of squares of yy. And the sum of squares of the error tells us how good is the fit of the model with our data. So it determines how tight is the regression line with our data points. The smaller the sum of squares of the error, the better our model fits our data. And if you still remember, we already have our ANOVA table from our analysis in Microsoft Excel. So to answer this question, perform the model utility test at alpha equals to 0.05. We would start with the null and alternative hypothesis. So the null hypothesis is B1 equals to B2 equals to 0 because we only have two independent variables. And the alternative is a constant. At least one value of our independent variable is not equals to 0. So this is copied from our results from Microsoft Excel. The test statistic, the value of the test statistic is over here, 25.8300. Okay, and I will not be using the statistical table in this case, but I would use the p-value over here. Okay, and as we have discussed in the previous chapter, the decision would be to reject the null hypothesis if the p-value is less than alpha. So our p-value is 0. This is 10 to the power of -5. So 1, 2, 3, 4, 5. So this is our p-value, 0.00004. Is this less than alpha? Alpha is 0.05. Okay. In fact, our p-value is less than alpha. So we reject the null hypothesis. And we can conclude that at least one of the independent variables is not equals to 0. Or this could also be written as the regression model is a good fit of the data. Okay, so over here, this is the regression model is not a good fit of the data. Okay, the null hypothesis would be that the regression model is not a good fit of the data. Okay, if we accept the null hypothesis, and if we reject the null hypothesis, the regression model is indeed a good fit of the data. Two of the most important values in the multiple linear regression model is the coefficient of determination, or the R-square, and the adjusted coefficient of determination, or the adjusted R-square. So what R-square does is it indicates the percentage of variance in the dependent variable, or y, that is explained by all of the independent variables in the model. Okay, so in our case, that would be x1 and x2. The value of R-square ranges from 0 to 1. Usually, these values are converted to percentage. So it is multiplied by 100%. So 0 becomes 0% up to 100%. And R-square of 0% represents a model that does not explain any of the variation in the dependent variable around its mean. And R-square of 100% represents a model that explains all of the variation in the dependent variable around its mean. Now, the adjusted R-square is actually a better measure than the R-square because it factors in the number of independent variables. So the adjusted R-square is a modified version of the R-square that has been adjusted by the number of independent variables in the model. Unlike the R-square, which increases when a new independent variable is introduced, whether it improves or it is not useful to the model, the adjusted R-square only increases if a new independent variable that has been introduced improves the model. So we could use the adjusted R-square to compare multiple models. Based on our Excel output, our R-square value is 81.1499%, okay, which means that 81.1499% of the variance in reaction time is explained by all of the independent variables in the model. Okay, I would write it out for us. 81.1498% of the variance in y, dependent variable, or in our case in reaction time, is explained by all of our independent variables. So it's explained by caffeine intake and IQ scores. So the R-square takes the value from 0 to 1. The adjusted R-square also takes the value from 0 to 1. We have another value over here, which is called the multiple R. So this multiple R is similar to the correlation coefficient in simple linear regression, except that the values are from 0 to 1. Another important hypothesis test for multiple linear regression is testing the hypothesis that the coefficient is 0. So we could test the hypothesis that B1 is equals to 0, or if it's different from 0, or B2 is equals to 0, or if it's different from 0. And if we have another variable, we could test whether B3 is equals to 0 or different from 0, or even if B3 is less or equals to 4, the alternative would be B3 greater than 4. Okay, I made a mistake over here, the test statistic. This should be B2, B2, and SB2. Okay, so similarly over here, the test statistic, if we have an extra independent variable, we have an extra coefficient, this will be B3 minus the population coefficient of X3 over SB3. Okay, so in this case, we would insert the value of B2 as 0 and even here as 0. But over here, we would insert the value of B3 as 4. So the critical value would be based on a t distribution. The degrees of freedom would be n minus 3. I am pretty sure that you could calculate the test statistic, the rejection region, and make the decision by yourself. Okay. However, this could be done easily with Microsoft Excel, and we have actually done it when we run the multiple linear regression analysis just now. So let's look at this example. Test the null hypothesis that the coefficient of IQ score is 0 at alpha 0.05. So at alpha 0.05, the null hypothesis would be the coefficient of IQ score would be B2 is equals to 0, and the alternative B2 is different from 0. Okay, so these are the results from Microsoft Excel. I would only look at the p-value over here. It's easier to make a decision. So the p-value for this test would be the one over here for IQ score. Okay, this is the test statistic. Okay, this is the coefficient of IQ score. Okay, so the p-value is 0.00001. Okay, which is actually less than alpha 0.05. So the p-value is less than alpha. We reject H null. Since we rejected the null hypothesis, the coefficient of IQ score differs from 0. The coefficient of IQ score differs from 0, or you can also write it as is not 0. Okay, so this is quite simple. We look at another example over here. So determine whether the amount of caffeine intake contributes significantly to the regression after the effect of the IQ score after the effect of the IQ scores is taken into account. What this question is asking is also similar to the question before, but it is for the first coefficient. Okay, so the null hypothesis would be that B1 is equals to 0. And the alternative is B1 is not equals to 0. Look, when the null hypothesis is rejected, okay, when this is rejected, this indicates that the independent variable contributes significantly to the regression model because y hat equals to a plus b1x plus b2x2. Okay, this is b1x1. So this is the estimated multiple linear regression. The actual model is written as y equals to a plus b1 x1 plus b2 x2 plus the error term. So if b1 is equals to 0, this indicates that caffeine intake does not significantly contribute to the regression if the effect of IQ scores is taken into account, right? Because B1 is equals to 0, you no more have the independent variable x1 over here, okay? But if the null hypothesis is rejected, this indicates that the independent variable, caffeine intake, significantly contributes to the regression model after the effect of the IQ scores is taken into account. Okay, this is contribute. This one does not contribute. Okay, so to make a decision, we simply look at the p-value over here. The p-value is 0.0058. Is this less than alpha? Okay, alpha is not indicated over here. Let me take alpha as 0.1. Is it less than alpha 0.1? Yes, this is definitely less than alpha 0.1. So we reject the null hypothesis. Okay, once we rejected the null hypothesis, we can conclude that the amount of caffeine intake contributes significantly to the regression model after the effect of IQ scores is taken into account. Okay, is taken into account. And you would continue writing that over here. Is taken into account. And finally, we could also calculate the confidence interval for the coefficients of the regression model. Okay, so B1 and B2 is directly calculated from the data or from your Excel output. The critical value T is based on a T distribution with n-3 degrees of freedom. Okay, SB1 and SB2 will be calculated using the formulas over here. And for example, if I have 3 independent variables, then we could easily write out the formulas for the confidence interval for B3. Okay, So to find the confidence interval for the coefficients of the regression model, I am taking the Excel output that we have created just now. Okay, so to find a 95% confidence interval for the coefficient of caffeine intake, this is the coefficient of caffeine intake. A 95% confidence interval would be from 0.0808, 0.3824. Okay, so the values are over here. The 95% confidence interval. While the 98% confidence interval for the coefficient of IQ score. So this is our IQ score. The 98% confidence interval would be from negative 1.3276 to negative 0.5920. Okay. Okay everyone, thanks for watching. I hope the video helps with your assignment, and I'll see you in class.